This is exercise 18.10, question number 1. The graph of y is equal to x square is shown in the diagram. Part A. Copy the graph using tracing paper and find the gradient of the graph at the points 2, 4. Okay, for this, what we need to do? We need to first of all jot down the point 2, 4. This is 2, and for this, y is 4 is here. So we can jot it down as this is the point. This one. Now we need to draw the graph at this point, or we need to draw a straight line on this. This could be the line. This one. Now to calculate its gradient, what we need to do? We know that the formula for the gradient is vertical change divided by the horizontal change. For this, now we need to see and we need to jot down uh, the points which are giving us some whole number value. So this is what we need to do. If this is 1 point and we need to see that this is the other point, so we need to observe how much is the vertical change. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8. And for the change in x or the horizontal change, 1, 2, 3, 4, 5, 6, and 7. So 7 boxes is the change along the x, that is horizontal change, or x change, and this is the vertical or y change. So we have used these number of boxes to calculate the gradient. So that gives us obviously 7 4s are 28. So the gradient is 4. Now one thing that we need to observe, that is this at this point the gradient is going up. The line is going up, that is the tangent is going up. So that's why the gradient is a positive value, positive 4. Now on the other side, in second part, when we need to draw the gradient at -1 and 1. So first of all we will jot down that point, -1 here and 1 here. So this is the point, and now we need to draw the tangent at this point. Let it be something like this. Okay, now again we need to calculate the vertical change and the horizontal change. We can see that 1, 2, 3, 4, 5, 6 is the horizontal change, and for the vertical change, that is going till here, that is obviously 2.1, 2, 3, 2.3. So 2.3 is the vertical change, and for x we see that it is going from negative zero point 0.3. Third small box is there, so each box is representing zero point 0.2 value. So this is 0.6, negative 0.6. Then 1, 2, 3, 4, 5, 6 boxes. So 6 times zero point 0.2, that is 1.2. And when we divide them together, so this is vertical change divided by horizontal change. Vertical change is now, you can see that its ending point is 0 and starting point is like 2.3. So for change, we do 0 minus 2.3, and for x, this was something 6 or 7 small boxes. So when we do it for 7 small boxes or 6 boxes, this is going to be 6 times 0 0.2, that is uh, negative 2.3 divided by 1.2, and that gives us, using our calculator, 1.91, 1.9. So this could also be having some value, like if we are having 6.5 small boxes, so this could be like this, and the answer could be, instead of negative 1.9, the answer could be negative 1.77 or something like this. So in this case, a minute variation of small boxes is possible, so that doesn't alter the gradient to a great deal. So that could be also the answer. Or if this is uh, instead of 6.5 small boxes, if someone gives it 7 times 0 0.2, that also makes the gradient uh, a correct gradient. So one thing, as you can see, the gradient is negative in both the cases. This shows that the gradient is coming downwards. That is, the tangent is steeping downwards. and the gradient of this tangent is decreasing. So that is shown by a decreasing line. So this is how we do the drawing of the gradient and calculation of the drawing of the tangent and then calculating the gradient. Okay, then it is part B now. The gradient of the graph at the point this is 3. Write down the coordinates of the point at which the gradient is negative 3. Okay, first of all, we need to jot down the point 1.5 for x and 2.25 for y. Let me zoom it in. 1.5 and 2.25. This is 1.5 and 2.25. Here is 2.5, and now in between this will be 2.25. Now if I draw a straight line here and then a straight line through here, it is given in the question that the gradient is 3. At this point, the gradient is given to be 3. Now you see, for the change in x and for the change in y, what we need to do, this one and this point. Let's see the change in x, 2, 3, 4, 5, and then 6. Change in x is 6, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, almost 14. We could have done it like this as well. This is second box, that is 0.4, and then this one was on the second small box after this 3, so that is 3.2. So it can give us something, this value, that gives us the gradient to be 3 as it was given in the question. So the point was 1.5 and 2.25. Now the question states that we need to find out the coordinates of the point at which the gradient is negative 3. Uh, the point at which the gradient would be negative 3 is going to be simple. The reflection of this x coordinate, that means it would be negative 1.5 and 2.25. That would give us a gradient of negative 3. If the gradient is 3 for this particular point, that means the gradient of negative 3 is going to have a point with the x coordinate having an opposite sign as to the point that is given. So x coordinate is going to be negative 1.5 if the gradient has to be negative 3. So this is how these questions are to be done. Question number 2 now. The graph shows how the population of a village has changed since 1930. This is the starting value. So this is the year along the x-axis and the population that is changing along the y-axis. Find the gradient of the graph at the point 1950 and 170. So we need to jot down that point first of all. For 170, first of all, we need to see how much is the length of each small box. You see 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10 boxes are there for 10 years. 10 years divided by 10 boxes. That means one box represents 1 year. Now for the y-axis, we see that these 10 small boxes represent population change in hundreds. So we can do it in a way 100 divided by 10, that is 10. That means this is 10, this is 20, this is 30, and so on. Now for 170, this is 150, 160, and 170 is here. Now we need to join it here. So this is the point at which we need to draw the gradient. So drawing the gradient, you see the gradient is going to be drawn uh, in the decreasing direction because the tangent is decreasing. So that gives us the gradient in a negative way. That would give us, obviously. So if we can just prolong this line further, we can have and we can prolong this line as well. This has to be a single straight line. Okay, now you see that if we find out the change along the x and along the y axis, that can be having some value like if I do it like here or here, this value, and then I do it for if I do bring it at some point to have the y-axis here, and then here. So these two lines, let me draw them neatly. This one, this is the change in x, and this gives us the change in y. So when we see them or we count them, that could be from here. Starting point is 40 and the terminating point is almost 250. So change in y is 250 minus 40, that is 210, divided by change in x. It could be from this one. So 1932 till this point, this could be 1978. So 1978 minus 1932. This could give us the gradient. So this is 210 divided by 46, which is almost 4.5, and it has to be in negative direction because the change in y is negative. So this can be this one, this one.